Okay, we're working on our boards for our power supply, and I finally got the plastic washers in, so I was able to oversize the emitter side holes. The collector side holes are the correct size. They're going to handle the power, so the screw is going to go through here and it's going to make contact. This side, however, the emitter side, has to be isolated. So we're going to put an isolation washer in there, and then it'll keep current from flowing from collector to emitter. We have some ultra-fast 5408 diodes here to prevent any reverse voltage issues. We've got our emitter degeneration resistors in. These are 0.1. So each transistor at max will be handling 3 amps. These are 0.1 ohms. So they're, and they're 3 watts, so we've got plenty of power handling. Yeah. 3 squared is 9 times 0.1 is 0.9. So really, 1 watt would do it, but we've got, you know, extra robustness built into here. We have our base feedback resistors, 330 ohms, and we've got a current limiting resistor of 1 ohm. That might be too much current limiting. Our beta is going to fall from, I think it's 75 to 30 when these transistors are pulling a lot of current. So that means that we'll need an increase in base drive as the collector current increases. I haven't tested this out yet or simulated it or any of that other stuff. I'm just kind of throwing caution to the wind and everything else, and basically hoping that this design works. Now we'll probably bench test this portion to find out how much current, how much base drive current we actually need in order to go full collector current. But that's not yet. So that'll be part of the torture testing. We're not there yet. We installed 40 mil sockets into the board. So this board is not just your ordinary everyday circuit board anymore. It's not just a garage shop build anymore. This is reaching, well, not professional level, but your professional level boards are going to have socket receptacles and things like that. The nice features that we like. So in case we destroy transistors, we can pop them out and we can swap them in. And it's also, of course, it's pinned to keep it located so it's not going anywhere. And we have multiple connection points. So we're going to copper strap this connection to the other board, which is mirrored. So there'll be a big copper strap going across it here. There'll be a big copper strap going across it here. And those will connect the two boards together. So we'll have one power point. And I'm really hoping that we don't have too much IR drop through there, and that the one group is pulling a lot more current than the other group. I'm hoping that it's semi-symmetrical. So that's kind of a prayer there. Hopefully it's not like 12 and 20. I don't think it'd be that bad. I'm hoping it's more like 20 and 18. That'd be okay. We have 9 power transistors. Now, to do it properly, the base drive, the main base drive transistor should be one of these, and the rest of them would be all power. So yeah, I didn't do that here. And that's because there's no temperature feedback. So to do it right, you really do need to have temperature feedback to your base drive transistor. It helps correct for any VBE shift because of the temperature rise. And that's going to happen. We know that's going to happen. So I don't know what I'm going to do about that right now. I might have to attach a high power Darlington transistor to one of the flats here to do the temperature tracking. I don't know. That's it's a fault of mine. I didn't want to design it in to this. I wanted as much power as I could manage. So I don't know. We'll have to see how much of a role that's going to play in the torture testing. I really hope it doesn't play too much of a role. If it's bad, I'll have to do these boards over again, which I know my customer's going to hate because it's already 4 years late now. But I'm doing it for him, so he's getting this thing out of this deal. So I don't know. We'll see. Part of the reason why I didn't include it is because I just don't know how it's going to perform at this time. I don't know what it's going to do. Now, if it runs cool enough, it won't matter. But if it runs hot, then we got a real problem. Then it's all going to go to shit. So, I don't know.